Hi everybody, welcome to week 4 of Chemistry and Society. Can you believe this is our 25% through the course week? Can't believe it. Week 4 already of 16. Let's take a look at what we've got going on as we start into week 4. Let's go on in. Oops, I've got some things still open here, it looks like. All right, so this last week you had your first exam. How did it go? Hopefully pretty good. The grades I'm seeing so far are looking pretty good. You had your carbon footprint lab. If you haven't completed that, remember you still can, but with a 2-point per day penalty. So you do want to do the labs, even if they're a few days late, so you can get some credit, because remember, 0 on your labs start counting against you, so be careful of that. Okay, so week 4, we're going to be doing chapter 3. We're going to be looking at radiation, and although we're starting into fall, boy, it sure feels like fall this weekend. But talking about sun, how much sun are you exposed to? It's pretty interesting to read this chart I have here of the average daily solar radiation per month. Not a big surprise, the Southwest has the highest, and as you can see, as we work towards Illinois, it comes down a little bit. But still pretty interesting information. Again, we're going to cover chapter 3, talking about sun exposure, skin cancer, sunlight, all sorts of things related to the sun, and even sunscreen and sunblock, which we'll do some more with that later in a lab, which is really fun. All right, this week then you've got chapter 3 to read and complete your Learn Smart chapter activity in Connect, the McGraw-Hill material. You've got lab 4, which is lab techniques and measurements. I'll be honest, this is probably one of your more difficult labs, and I'll talk more about that in a minute. And then our second movie, which is called The Poisoner's Handbook. I think you'll actually find this one pretty entertaining. It's pretty interesting. So that's what you've got going on. Let's go back to our modules here and see what's happening. So you can watch your short video on chapter 3 of the textbook, PowerPoint for those that like to have that. Again, I recommend you keep those for when you're reading through, maybe taking some notes, and then when you're working the next exam, use that as you're working through the exam, as your kind of cheat sheet. Here's your movie and the Dropbox for submitting your summary. Only one thing as a reminder from what I saw in the first movie. Remember, 1/2 of your essay is to be a summary of the movie. The other 1/2 of the page of the essay, one full page, is to be about why I picked it, how it relates to the class, to what you're learning, things like that. This one's pretty obvious just because it's about chemistry, but that's your breakdown of your summary. One full page. I don't need a title. I don't even need your name on it because I know it's you. You're submitting it. Written in your own words, not copied, and double-spaced. Times New Roman, size 12, double-spaced. I kind of went through how to do that in Word couple weeks back, so if you need to go back to, I think it was in week 2 I posted that. If you need to go back and review that, review that. Pretty basic requirements for the movie. Again, half credit for the summary, half credit for the how it relates to the class. Okay, lab 4, lab techniques. This is, as I said a minute ago, this is probably one of your more difficult labs. I'm going to kind of log in here and show you what it looks like. First of all, don't stress yourself, okay? Take your time. I would work on this. It has many parts. Work on maybe 1 part a day. And let me go to the lessons. Remember, these are not in order. So you're doing lab techniques and measurements. You have several different exercises. And again, I would probably break them down. I really recommend you do exercise 1 one day, where you're going to measure length, temperature, and mass of different objects. Then you're going to do exercise 2, volume and density, and then finally exercise 3, concentration, solutions, and dilutions. And so you should review the exploration first, but I'm going to jump right in here just to show you some shortcuts. So in exercise 1, again, here's how to use your digital scale. Make sure you watch this video. Then you're going to take length measurements of several different things, record that on the data sheet. You can read through all this. You're going to take temperature measurements of several different things that you're going to do here. You're going to heat up some stuff, heat up some water here. Okay, measure the temperature. Read through all this. Okay, your setup's going to look like this. That you're going to warm up some water, heat up some water in a beaker, and then measure the temperature. Okay, read through all this. Then you're going to take the mass of several things. Pencil or pen, pennies, quarters, dimes, and a key. If you don't have these things, guys, exactly, don't worry about it. Grab a couple of things and just take mass measurements. That's the purpose of the exercise, is to take some measurements using the balance. Okay, a couple of things. It's really, really important, and this is going to be important in density as well. When you want to take the mass of something, and it shows you this at the video at the top, but I'm going to reiterate it again because it's important. You need to zero the button, push the zero or tare button first with nothing on the balance, saying this is zero mass. Then put your item on and look for the number next to the letter G. G means grams, and record that. And you're going to do that over and over and over again. Before you put any object, push the zero, and you're going to do all these different things as it says here. And then you're going to do some conversions from mass into, or excuse me, from grams into kilograms. Remember, 1,000 grams equals 1 kilogram. Okay, then you're going to answer all those questions. Exercise 2, and that one's not too bad of a exercise. And I would do that in one day because that's going to take you a little bit. All right, then the next thing you're going to do is measure mass and volume of some different substances to then calculate density. Remember, density is mass divided by volume. Now, some important things here, and this is where I find a lot of students make a mistake. Because you're measuring the mass of a liquid, you can't just pour the liquid directly on the balance. That would make a mess and it wouldn't stay. So what you do first is you put a container on the balance, your graduated cylinder, and you push the tare button. So when it says a tared scale, that means with the graduated cylinder, push 0 or push tare and have it read 0 grams. We don't want to know or include the mass of the cylinder. We just want the mass of the liquid that's going to be added to the cylinder. So put the cylinder on, hit the tare, make sure the balance reads 0, and then, as it says here, add 5 milliliters of distilled water using your pipette, pouring it in really however you want to do it, but just add 5 milliliters. Record the volume, which should be right at 5 milliliters, and the mass. Well, how do you know the mass? Well, if you put the graduated cylinder on the balance and tell the balance this is 0, and then you add 5 milliliters, you should have just the mass of the liquid. And I'll give you a hint for this first one. The mass should be around 5 grams, but record exactly as it is. If you get a mass of around 30, you did not tare or zero the balance first. I don't want to include the mass of the graduated cylinder. Again, that's not what we're determining density. It's just for the water. Okay? Or you can do the following right here. You can calculate mass by subtracting the mass of the cylinder from the mass of the cylinder plus the liquid. So one of two ways to calculate mass. To get the mass, of the liquid. Put the graduated cylinder on, push 0, then add 5 mils of water. Or zero the balance, put the graduated cylinder on there, write down what it weighs, add the liquid, write down the new mass, and the difference between the two is the mass of the liquid. Either one of those works as your calculation of mass. But again, your hint, it should be around 5 grams. Okay? You're going to do this mass and volume calculation for determination for water, calculate density. Then you're going to do the same thing for isopropyl alcohol. Same method, same procedure, but you should have slightly different numbers. Calculate the density and record it. Kind of a hint here. Density of water should be around 1 gram per mil, and for the alcohol it should be 0.786. So knowing these two accepted values, and you calculate the density of both, figure out what the percent error is. Hopefully your percent error is right around 0, that you get a pretty good number. You're not marked off if it's wrong, okay? You're marked off if you do the procedure wrong or you're way out of whack. So again, this is your hint. They should be in this ballpark. Not going to be exactly identical, most likely, and that's fine. But from there, your experimental is what you get from the experiment. Accepted are these two values, depending on what you're calculating the percent error for. You're going to do it for water, and you're going to do it for the alcohol. Okay, then you're going to do volume and mass determinations, and therefore density calculations for some solid objects. These instructions seem to work a little better for students, and I don't have as many issues, so I'll assume that you can just do this yourself. Okay. All right, then the last thing, you're going to do a solution. You're going to make a solution. And again, watch this video, please. Follow these instructions very closely. Basically, what you're going to do, you're going to make a sugar-water solution. Okay, that means sugar in water, 8 grams of sugar, and it's supposed to be 15 mils of water initially, but then you're going to add up to the 25 mil mark. So here's your hint. Your mass should be around 8 grams. Whatever it is, whatever exactly you have, it's not going to be exactly 8 most likely, but write that down. And then your volume should be 25 milliliters. You're going to need that mass and that volume to calculate the concentration. Here's your percent mass volume concentration calculation for your solution. So mass should be around 8, total volume should be around 25, but use exactly what you have. Those are just kind of your ballpark numbers, okay? And then from there, you're going to follow these instructions and you're going to dilute it. You're going to dilute it. So you're going to take that concentration and dilute it, and you can follow all these instructions. Okay, you're going to pull out some from the original, you're going to add to an empty and add more water, diluting it. Okay, here's your concentration calculation. C1 is initial concentration, so that should be back to that beginning up here of your original solution that you make, times volume. How much did you pull out? 15 milliliters, 10 milliliters, however much you pulled out of that original container, equals your new concentration. That's what you're going to calculate, times volume. What's your new volume? Is it 25 mils? It usually is. All right, and then you're going to record all those. You're going to do that 3 times for these different volumes. Put it in the table, and then you're going to create a graph. You can follow these instructions here. And for cleanup, this is just sugar water, so down the drain it goes. I'd use a little soap and water though, because it might be sticky. Otherwise, guys, that's it. And again, this is quite a lot for one experiment. I recommend you do exercise 1 on one day, 2 on a different day, 3 on a third day, just not to overwhelm yourself. If you have any questions, let me know. Then come back to the class, upload your PDF from the lab itself, and then you need a picture of you holding your sugar water solution that you made, that initial solution, and a sign. So take a selfie, I know you can do it, with the sign and your solution if you can, and submit an assignment when you're done. That's it, guys. Have a great week, and I'll talk to you in week 5.